All right, today we're going to solve some square root and cube root equations. And to do that, we're going to isolate the radicals, and then we do the opposite. The opposite of square rooting is to square, so we'll be squaring both sides of the equation. The opposite of cube rooting is to cube, so we'll be cubing both sides of the equations. So squaring and square rooting are opposite operations. Cubing and cube rooting are opposite operations. Just like adding and subtracting are opposite. So you must isolate the radical first. So on problem 1, the radical is isolated. So I can just say, hey, what's the opposite of square rooting? So then I just put some parentheses here, and I square both sides of the equation. So squaring and square rooting cancel out. I have x minus 1 is equal to 3 squared, which is 9. I'm not allowed to touch this 1 here because it's inside the square root symbol. Now I can get to it, right? So it was like inside here, it was like inside of a force field. Now the force field's neutralized, and I can get at this 1. So the opposite of minus 1 is to add 1 to each side of the equation. I get x is equal to 10, and that's the solution. All these problems on the front page you need to check because you can get something, you can get the wrong answer because you're turning it into a different kind of equation. So I'm going to put the 10 back in here. 10 minus 1 is 9, the square root of 9 is 3. That's good. We move to the next question. Okay, number 4. I'm going to add 4 over because you must isolate the radical symbol. So this 4 is out here and it's vulnerable. It's not inside the force field. So I can get at this 4. So I'm going to add the 4 over. And I get the square root of 3 minus x is equal to 4. Then it looks like the last problem. So I'm going to square each side because that's the opposite of square rooting. And we get 3 minus x is equal to 16. Then we solve like we would solve a regular algebra problem. We're going to subtract 3 over. And we get negative x, because the negative drops down, is equal to 13. Divide each side by the negative, x is negative 13. So we need to check to make sure that this works. So we put negative 13 in there, so it'd be 3 minus a negative 13, which would turn it into the square root of 16. The square root of 16 is 4 minus 4 is 0, so that one works. Okay, number 7. So as you can tell, I'm going down this left column, and then you'll be able to do the other ones, the center and the right column. All right, so this one here, isolate the radical. So I can have access at this 6. Here I had access to the 4, but not the 3 because it was underneath the radical symbol. So I'm going to subtract over the 3, and I get the square root of x is equal to negative 6. I square both sides because that's the opposite operation, and I get x is equal to negative 6 squared. If you don't put parentheses on this, it won't square it right on the calculator, but negative 6 times negative 6 is 36. Now, this one here is an issue when I put it back in because the square root of 36 plus 6, does that equal 0? Well, the square root of 36 is 6 plus 6 does not equal 0. It equals 12. 12 is not 0. So this one has no real solution to it. Right? There's no solution to this one. No real solution. All right? So 36 doesn't work. And there's a couple other whammies on this. All right? So basically, this one here, you can just go ahead and square both sides because the radical is isolated. But on this one, not, right? You got to move the 9 first, then square both sides, okay? So that's the theme on this. So the opposite of square rooting is to square. The opposite of cube rooting is to cube. So on the back side, we're going to be cubing both sides of the equation. Because what you do to one side, you do to the other, all that business. Here, you can take the cube root of negative numbers, so we shouldn't have to worry about checking these as much. It's because a cube root function and a square root function are different from each other. So is the radical isolated? Yes. So I'm going to cube both sides. That cancels out the radical symbol, neutralizes the force field, if you will. X plus 4 is equal to 3 times 3 times 3, which is 27. 3 cubed is 27. That's on your pink paper. Minus 4, and we get x is equal to 23. All right, does that make sense? 23 and 4 would be 27. The cube root of 27 is 3. So this is the correct answer. All right, again, the name of the game is isolate the radical symbol. I can't have access to this until I cube both sides, but I can move this 4 over. So I add 4 over, and I get the cube root of 3 minus x is equal to 4. Then now it's like the last one. I'm going to cube both sides. So that neutralizes. I get 3 minus x is equal to 4 times 4 times 4, which would be 16 times 4, 64. Again, that's on your pink paper too. 4 times 4 times 4. Subtract 3, and I get negative x, and the negative drops down, is equal to 61. Divide over the negative, I get negative 61. So negative 61 is the answer. If you put it back in, 3 minus a negative 61 would be 64. Cube root is 4, right? So it does work out. Okay, next question. So the 5 is dangling out here, but I can't have access to this yet. So I subtract 5, subtract 5. Now this negative falls straight down. Gravity makes it fall down. Cube root x plus 1 is equal to, okay, you owe your uncle $1, and then you borrow 5 more, right? So you owe 6, so negative 6. This negative 1 is dangling out here, so I'm going to divide by negative 1. So a negative, you can pretend there's a 1 there. Negative divided by negative is positive, so I get cube root of x plus 1 is equal to 6. Now we have the radical isolated, so I'm going to cube both sides, because that's the opposite of cube rooting, and I get x plus 1 is equal to 6 times 6 times 6, which is 216. Then I subtract 1 over, x is equal to 215. If you put that back in, you're going to get 215 plus 1 is 216. Cube root is 6. 5 minus 6 is negative 1. So it does work. All right. Ta-da! So we did 6 together. There's now 12 for you to do on your own. All right. So have fun doing that, and I will see you later.